Rosh, if you speak, could you just try it?
Sorry.
Just try it. Okay. Yeah.
Can you hear me now? Yeah. Great. Can people online hear?
Yes.
Great. Right, we'll start again. Good morning, everyone. I'm Lucy. Thank you all for coming today. I know it's early. I won't take long. I'm just about to introduce Rosh, who unfortunately has a bit of a cold at the moment as well. So please bear with her. So I joined Zinc in January to kind of help start this new inflection program. It's at Zinc, we've been venture building for the past kind of 8 years, and a lot of people, we joke, people come to us at what next moment. So often that's to go and build a new startup, a new venture, but we've also realized that that path isn't for everyone, and there are many different ways we can create impact and create impactful innovations. So the Inflection Fellowship is really a group of people who are motivated by impact and interested in finding alignment between their passions and skills and also what the world needs. And that goes beyond a venture-backed business. So please, we've kind of thought a bit about what might be interesting and what sorts of topics the group is interested in. Rosh is part of our pilot cohort, which we kicked off in May, and she's apparently been inundated with requests and asks and questions about AI. So a bit of background from Rosh: she spent 20 plus years at JP Morgan building sort of expertise in financial modeling, and from that has moved into AI, has worked and advised in many AI startups, particularly in the health tech space. I'll also let her introduce herself. Today will be presenting some of the projects she's built and some of the products. So yeah, I mean, we'll do about 20-25 minute presentation.
Probably be 30. I'll
30?
try and minimize
okay,
it.
No, that's fine.
Yeah.
And then we want to have, I mean, it'll be interactive. We'll have plenty of time for questions, and it's really time for you to learn, ask questions. Afterwards, we'll do a bit of networking. We've got a lot of people online as well, so we'll put people online in breakouts. That's enough from me. I will hand over to Rosh.
Hi, can you hear me? Can everyone hear me online? Everyone okay?
Yes, we can.
Cool. Thank you, Lucy, for that wonderful introduction. Good morning, everyone. Nice to see so many people come bright and early for this exciting topic, demystifying AI and the new era of work. A little bit about me before we begin. I work at sorry, we're just going to have to bear with. Okay. A little bit about me. I work at the intersection of AI, impact, and innovation. I am the CPTO at a neurotech startup. We use AI quite foundationally, and we use a lot of types of AI, some of which I'm going to talk about in the presentation. I'm also a Zinc Fellow, as Inflection Fellow, as Lucy mentioned. And I have a previous experience in product tech and quant roles, specifically in digital transformation, robotic process automation, which is RPA, and predictive analytics, and many other areas. I just want you to hold on to some of these concepts because we'll contextualize them as we go along in the presentation later on, and how that evolves into AI. In my spare time, I like using a lot of generative AI applications. I like experimenting with them, and hence all the lovely digital avatars that I get to be, sometimes in Indiana Jones, sometimes an alien from another world. So I like to experiment a lot with new generative AI and agentic applications. So the topics we're going to cover today, we'll try and keep it as high level as possible, as simple as possible. A lot of the concepts that we talk about are fields of study within AI themselves. So it's not possible to potentially go or do a deep dive in a 25-minute presentation. But I can promise you that you will be able to, after this presentation, classify various types of AI. And I will give you some hacks and productivity and other tools that I use or have built, which you can instantly go back and start using yourself and will hopefully help you in your day-to-day work and your life. So let's start with this diagram. I'm assuming that has anyone here heard about deep learning, or how many of you have heard about deep learning? Great. Do you understand what it is? Okay. Maybe intermediate, beginner, something. So we can start with the high-level contextual map, which is artificial intelligence, meaning what do computers do to act like human beings or anything that a human being could do. We come one level below and we talk about machine learning. What machine learning does is it enables systems or computers to learn from data without any kind of explicit programming. And it is of two types, in the sense supervised and unsupervised machine learning. So unsupervised machine learning would use an unstructured data set, whereas a supervised machine learning would use a structured data set with labels. The next thing is, when you come a level below, you have deep learning or neural networks. And this is a specialized form of machine learning where you use artificial neural networks, which essentially act like the human brain in order to solve machine learning problems. When you come a level below that, you come to generative AI. This is something that you hear a lot, but a lot of people don't realize that generative AI is actually just a subset of machine learning and a smaller subset of deep learning. So generative AI uses deep learning and artificial neural nets to generate language, images, videos, and many more things, sound as well. When you come a level below that, if you take the language aspect of generative AI, and we'll talk about what other aspects are there, you get to LLMs, or large language models. So you, again, get this concept thrown around quite a lot. But what a large language model essentially is generative AI that uses language or generates language. When you come a level below that, then you get a GPT, which a lot of you have again heard in the context of possibly OpenAI. But a GPT is just a type of a large language model that uses something called the transformer architecture, and we'll talk about it in a further slide. And it's pre-trained on a large amount of data set of text or language. A GPT further down then can be an actual GPT model, which is like a GPT-4, Omni, various other OpenAI models. But the ChatGPT is the product then of OpenAI that runs on GPT-4. Now, in the same way, you could have Gemini, which is a Google model, that also has its own products, but the underlying model is called Gemini. I'm assuming this is clear enough now. We will keep referring back to this diagram as well. So I was going to do an animation with this, but the animation won't come up in the docs end. So let's just go through it as we can. So let's just do a word prediction game, right? If I tell you question 1, the sky is, can you, blue, okay. But what if it's night? So it would be dark, it could be black, it could be many other things, cloudy maybe. If I tell you question 2, I'm looking outside the window, it's morning, and is the sky is? Okay, if it's morning, then it's potentially blue. I'm in London, looking outside the window this morning, and the sky is? Exactly. So essentially, what I'm doing here is I'm trying to arrive at the fact that what is important here is the context. If the context was that the sky is, there could be a lot of answers, but if I narrow the context down for you to it's morning, you may think that the sky is blue. If I narrow it down to London, a lot of people will say the sky is gray. So context is what makes the large language model intelligent. And there are a couple of concepts. Again, I'm glossing over a lot of technical details. So if you do have questions, we can obviously discuss that later on. But two concepts that you need to remember are vector embeddings. Essentially, this is a very large data store that holds these concepts that are closely related together inside its data store, in the sense that blue and sky will somewhere in this data store be closely aligned, and hence the model is able to predict that since sky and blue are near each other, I should predict blue in this case. And also, this is the neural network that we spoke about. And essentially, when you combine the vector embedding with a neural network, what you get is these probabilities. And if you are from a math and a computation background, obviously, you would get what a probability is. Or if you don't, you just assume that it is the likelihood of that word coming up. In the sense, the likelihood of all of these words, the sky is calculated as these probabilities, and blue is the most likely probability of the next word. So what you need to remember, sorry, one more concept is that there is also randomness built in the sense that you won't always predict blue, or the model will sometimes predict a different answer. Hence, when you type into ChatGPT, sometimes you get a different answer than, or more often than not, you get a different answer than you got the first time, or it just rejigs the words around. So what an LLM is they don't really know what the world is. When I ask you to describe the sky, you're getting a sensation of the sun, the blueness of the sky, the feeling of the sky. An LLM doesn't exactly have that. What an LLM is doing is guessing the next best word or the next best sentence based on the patterns in the text. And the more context you give, as I said, the smarter the prediction is going to be. Again, I'm sorry, the animation won't work, but this is actually two programs that are written. Again, these are both open source programs available, and I can give you the links later on. All the sources are marked. They actually show you every single word, how the probability changes. So if you play the animation, I'm not sure whether we can at the moment, but it's fine. If you play the animation, you'll see how the prediction of every word as you go along, or the autocomplete, changes with the probabilities. And similarly here, this animation actually shows the hidden layers of the neural network, how it does the calculation. And again, these are open source programs. They are not quite the size of an LLM, but they are much, and just for illustration. Two other concepts you need to remember, and again, this is something that people have heard about but don't quite know what it means. This started, all of this architectural innovation started with the 2017 Google research paper on attention and the transformer architecture, which gave this whole explosion of various LLMs. This is a very heavy paper, but I will show you a hack later on how you can go through that paper without deep diving into a lot of the technical details. And since then, which in the world of AI, 2017 to 2025 is a very, very long time. There's been a lot of innovation on this attention architecture. You have something called multi-latent head attention, mixture of experts, lots of research going on. And I think these are the secrets, or these models are the secret behind why you're getting cheaper and newer models like DeepSeek come up and beat the pricing on things like OpenAI. Okay. Now, again, I'm not going to go into the technical details of how other Gen AI are done, but it's good to know what these are. So I'm always excited about LLM special cases. When I say LLM special cases, a lot of people ask me what that means. But for me, the understanding is that code, for example, is a special case of language. It is a type of language. So you have code generators, which are also large language models. And now, pretty much with Cursor, Lovable, various other kinds of such code gen applications, you can pretty much write your own code. Similarly, legal language, or the context in which you sequence words that it becomes legal language, is a special case of an LLM. And hence, I've marked them out as special cases of language models. What other kind of Gen AI are there? Sound generators, voice. I use Synthesia quite a lot. It's an excellent sound application. Music generators, Suno AI. Suno is an absolutely excellent music generator if you want to use it. I mean, I've created my own poems and put them to beats using the sound generators. And again, I think everyone's familiar with image and video generators. I won't go too deep into them. The one I started using initially was DALL-E, but I think I've moved now to Stable Diffusion and Midjourney. And you also have video generators. I really like the Hyla one, but Sora Runway are also great. And then you also have combined generators, in the sense that what if you want a document or a PowerPoint presentation that doesn't just have text? It also has language. It may also have images. It may also have a video. So you have Canva, Gamma, all of these kinds of AI applications which do combined Gen AI of various types. Similarly, if you are into product management or you're into some kind of technology, business analysis, you might even do graphs and flowcharts. And again, that requires image as well as text. So that's a combined generative AI. So here you have, if you go further up now from the generative AI section, which we spoke about, you come up into deep learning. There are other applications of deep learning that also are within the frame of artificial intelligence, but are not specifically called Gen AI. We'll see why they are important again in the following slide. But one of them is computer vision. That is a field of AI that enables computers to see. And where is that useful? In autonomous vehicles. Have you heard about Waymo and Tesla, autonomous driving? You also see that in healthcare, in the sense that assisted medical image analysis also uses computer vision. You have motion or movement capture, which plays a crucial role in training robotics or robots to be like humans. That is also, other kinds of AI. And it all falls within the scope of deep learning, in the sense that it uses these machine learning techniques called reinforcement learning, and also uses neural nets. I have marked robotics here. It's not a field of AI or doesn't come under the subset. They're both distinct fields, robotics and AI, but because robotics focuses more on the physical aspect of machines. But you can assume, for the sake of this discussion and widely, that robotics uses AI. So robotics will use computer vision. It will use movement and motion capture. It will use large language models for the robot to speak, computer vision to see. So robotics uses AI. Okay. So we hear a lot about AGI and superintelligence. Are all the robots going to come and kill us? Or, is there going to be wide chaos in society when there's a superhuman intelligence around? Or are we all going to lose our jobs? So just to frame that discussion, there is another set of classifications that you need to understand. So you have narrow or weak AI. And what is weak AI or narrow AI? I mean, it's by no means weak in the sense that it does exhibit intelligence like humans do, but it is only for a specific task. Then you have general or strong AI. So when you say general or strong AI, you're usually talking about artificial general intelligence, which is all the hype at the moment. This is still a theoretical concept. It's not around yet. there are lots of obviously articles and people saying that we are getting closer and closer to it, but we don't know. There are many hypotheses of how this might come about. And then you have superintelligence. Superintelligence is when it surpasses human intellect. In some sense, in a philosophical sense, that is bound to happen because, we have access to a certain amount of data, whereas an AGI will have access to a lot more data if you throw more computation and memory at it. Now, all the AI that we have covered, it's important to remember, is narrow AI. It's for a specific task. You cannot tell a GPT to go see something outside and tell me how it's going to be. It can't do computer vision. Whereas you can't tell a robot what a GPT is going to do. So all of this AI that we've discussed is for a specific task. And the next thing to remember for the next slide is that language is a condensed form of intelligence. If I describe to you that I had an orange, there is a lot about what I just did that you have already mentally made a model of. That orange is orange in color. It's probably got small pieces inside. It was probably tangy, slightly sweet. There's a lot about that orange and the fact that I ate it that you can imagine and think about. So language gives you that condensed form of intelligence. However, the corollary of that means that even though it's a condensed form of intelligence, it doesn't get all the data that you would get if you were not to have language, in the sense that if I were to have to tell you that or in some way describe to you that I had an orange, and I didn't have language to tell you that, there's a lot of other data that I would have to give you. You'd probably have to touch the orange, you'd have to feel it, you have to see it, you'd have to taste it yourself. So a lot of other senses would come in, and hence a lot of data would collect because of that. So if we keep focusing on language or LLMs or generative AI, it is quite unlikely, I wouldn't say not likely, but quite unlikely that you will get to strong AI or get to AGI, because there's a lot of data that goes into intelligence that you are missing. That brings me to this AGI modularity hypothesis. Now, it's important to remember that it is a mental model and it's a hypothesis, and there's a lot of research ongoing on it. So do not take this as a given. There are many such hypotheses out there for AGI. This is just one of them, and this is the one that I genuinely like, and I have seen a lot of scientists also talking about it recently. So the hypothesis is that each AI subfield is like a region in the brain. So you think of LLMs as a language center. You think of CNNs or computer vision. CNNs are basically convolution neural nets. It's a subclass or a specific type of neural net that allows you to train on computer vision. You think of that as the occipital lobe, and the occipital lobe is basically what interprets your eye signals or your eyesight. So these centers are various of your brain, can each be a subfield of AI. And if we want to get to AGI or human intelligence, we get there by making proxies for each region of the brain. So we construct models for each region of the brain, and that's how we get to AGI. How or why you can do this? Again, there are various papers out there. This is one which I'm currently trying to read. It's called the Hippocampal Memory Model, and it's discussed. I've given the source in Journal Club IO as well. However, if this is again a very dry subject for you to read, I will show you a hack on how you can do that in a later slide. Okay, then we come to agentic AI. I'm going to cover this very quickly because there is a lot in agentic AI, and there's a lot happening in this field as well, and I don't think I will have the time to cover everything. So think of agents now as autonomous AI. It's still narrow AI, it is still task-based, it is not AGI, but it is automating your workflow. So for example, you go to GPT and you type a query every single day around, I want to write a LinkedIn post for what I did yesterday in my startup. You are physically doing that action. You can have an AI agent do that for you, in the sense that the agent will have access to GPT, to your tone of voice, how you speak, what you say, and how you say it through your past data, and it will do that in an autonomous way on a daily basis. And then you have various types of agentic architecture. So you can have a single agent, which means you have a personal assistant or a chatbot, which acts as your chatbot, or fixes, for example, your meetings. You could have multi-agent systems, in the sense I have a personal assistant, Lucy has a personal assistant. They're both AI agents, and they are talking to each other and fixing a time for us to meet, so that we don't have to do that, and we end up saving time doing that. And then you have the human-machine interaction, which is quite obvious, in the sense I have a personal assistant, someone else doesn't. So my AI agent interacts with a human in the loop, and fixes a meeting for me. Just some more context around AI agents. As I said, autonomous task execution, but what you need to remember is two things, right? Why is it possible? Why is there an explosion of AI agents? So there is an MCP protocol. Essentially, an agent needs to know how to connect to the various tools. So it's able to connect with this MCP protocol to the various tools and APIs. For example, ChatGPT has an API, so it's able to connect to these tools. It's able to connect to your Gmail using this standard way of connecting, which is called the MCP protocol. And now you have the Google's A2A protocol, which is agent to agent. In the sense, there is a standard way for an AI agent to talk to another AI agent using this protocol. Agents can do chain reasoning. As I said, they can do multi-step operations, in the sense they can go research things for you. They can summarize things in that research, and then they can go and send an email for you. And they will have access to all of this, again, because they have access to the tool set through these APIs and the MCP protocol. They are also capable of memory. ChatGPT sometimes does not remember what you mentioned last. An agent will remember that this is what you were researching on, and it will add to your research the next day. And again, some real world use cases, scheduling assistants, customer service bots, research co-pilots. And I just put these two pictures because, when you think of an AI agent, you think of someone who's like an AI coworker, someone who looks like this. But in reality, this is how we build agents. It's basically just workflows. So this is an actual diagram of an N8N agent that takes messages from telegrams and sends it to a Gmail agent. So it's not extremely glamorous like AI worker. It's mostly at the moment just like a workflow. Okay, so I want to cover very quickly, I don't think I have too many slides on this, on AI foundations and the future. So in the workplace. So you remember I mentioned digital transformation. So digital transformation is a broad term for all the technologies that began in the 2000s and 2010s. They were accelerated by automation, cloud, mobile analytics, a lot of the tech that came up at that time, like cloud services, like mobile technology. That drew a huge wave of digital transformation. And you also saw that there was a culture change within organizations. There was a lot of process redesign, a lot of business agility that happened because of digital transformation. And the types of digital transformation that were happening are RPAs, or robotic process automation. When I usually mention, like I said, I did work on RPA, but when I usually say RPA, to people who do not have the context, they think of AI agents. But robotic process automation was at that moment just programming a set of repetitive tasks that people used to do every single day. It didn't have any intelligence built in. It was just workflow automation. It was part of digital transformation. And again, you had intelligent automation, predictive analytics, cloud computing. And Some of them did have machine learning built in, not to the extent of deep learning that we do today, but it did have some statistical machine learning methods built in. This laid the foundation for AI adoption. And you can think that digital transformation was the runway that helped this plane of AI to take off. Sorry for the images of not of a plane, of a rocket, because I think my AI was just overzealous in its depiction. So now you see this shift in the last 3 or 4 years happening from digital transformation to AI. So a lot of organizations are revamping their strategies, and you see this explosion in AI capabilities. And this is faster than any previous tech wave we've seen. So you had the dot-com boom in the early 2000s, which was the internet. And then you had the mobile boom, then you had digital transformation, but AI is superseding all of them in the pace of scale and adoption. And this is just, for me, these 4 concepts are from 2 books that I have read. And they form a mental model of how AI can disrupt workplace, like how digital transformation did. And I'll refer the books later on as well. However, there are a couple of things which we need to remember or learn from the previous disruptions in the tech space, like digital transformation, like cloud computing, etc. So AI is a system level transformation. It is not task automation anymore. And the best way I can describe this again is by giving you an example. So think of medical diagnostics and a radiologist's job. So you are automating their task, as I said, through computer vision. But is it just automating their task? In the sense, are they just going to have an AI do their job? It is most likely going to disrupt their workflow. In the sense, the most complex cases will come to the radiologist now for validation. They will come to, if there is an error, that will come to the radiologist for validation. So the entire chain of, or the workflow of how things are done in healthcare, in medical diagnostics, will get disrupted. And it is not just about automating that task and taking that job away. So you need to have a higher level understanding of what that task automation is going to do to the actual workflow. Then I think the other one you can see is the human AI tensions. These are going to be structural forces. In the sense, again, another example, take an AI tutor. Because of agentic AI, everyone can probably in the future afford a personal AI tutor, an AI agent who's your tutor. That is great for the consumer and for the customer, but it will cause friction and tension with the AI education provider. Because their margins will come down. Their tasks and their workflows will be disrupted. The way they make money and their business models will get disrupted. So there are going to be some stresses in these, or tensions in these structural forces, which will also have a lot of opportunities. The other thing that institutions or large organizations or even small organizations need to remember is that their strategy has to change. In the sense, they have to look at AI as a strategic build out, like how they thought of digital transformation as a strategic build out. And I think the example I can give, I don't have a lot of details, but I believe Amazon, in the way it's doing its warehouse models now and building AI into it, is a very good example of this. It's not just workflow automation. Go to the next slide. Okay, now comes the fun part, AI applications. Can I just ask with a show of hands, does anyone know any application that shows you all kinds of AI? You can go and search. You do? Okay, good. 1, 2, okay, cool. So how would you go about searching for an AI application? Just Google search? Okay, has it been useful to you? No, okay. So here is an application, not really an application, but a website. There's an AI for that. It's open, it has a free mode, It gives a lot of things free. And this is an example of a Gen AI query for music, a generative music that I ran. And it gave me all of these music generators. And the one that I used was not even in the top 10. I did the same search on Google. Unfortunately, I didn't have space to show that here, or the animation won't show, but it wasn't the same. There's probably about 30,000 AI applications or even more and growing that you can do or you can run on this or search for on this application. What I really liked, and I discovered this yesterday, that they have a list of free tools available. So a lot of AI tools are now paid for, but you could get like a list of free tools there. And they have a free image generator. So I was actually paying for image generators. I don't know how good this one is, but I discovered that they had that one. Was it the same one, Lucy? Okay, maybe we should get your suggestion as well. Okay, this is again just a very general frame of, and again, this is not my image. This is correct as of September 2024 from this RapidOps site. So yeah, so you can see the number of Gen AI applications. These are again just the top ones in generating code, text, video, image, speech, and 3D. You can see that code and text are the widest or the largest applications. And some that I use for my own productivity on a day-to-day basis are text generators. So ChatGPT, Claude, Perplexity, particularly because it uses RAG, or it gives me the sources where it is searching from. Documents and slides, I use Notion and Canva a lot. Automation and AI agents, I've used N8N and Zapier. I like N8N a lot. I think people can get a lot of value out of it, but Zapier is much easier if you do not code. And Replete agents as well. And then you've got chatbots like Bot Penguin, leadership tools. Again, I could not put some of them over here because they weren't open or open source. They were mainly B2B, but if you come up to me later on, I can give you some names. Okay, this is the hack that I was mentioning earlier. If you do a lot of research, and a lot of deep research, a lot of technical papers, and not necessarily even technical papers, a lot of other information from websites that you collect, from PDFs that you collect, what you can do is you upload all of these sources, PDFs, videos, websites, and in my case, these research papers that I mentioned earlier with some kind of deep subject matter, you upload that into Notebook LM. It's a Google product. I think there is a paywall as well, but it does have some form of free version. And then that AI becomes your personalized expert on that deep research topic. It cites sources and it doesn't just answer, and it uses the underlying Google Gemini models. However, what's interesting is that the voice feature turns that deep research into an engaging podcast conversation. Right? So you can listen to that deep subject matter, which would probably put you to sleep, but also be entertained because it's quite an engaging podcast. And I've done this, many a times while I'm bored or sleeping, and that's how I managed to get through the attention is all you need paper. Okay, this is now Gen AI plus agentic for a personal use case. So this is by Thinkly Labs. These are two of my product mentees, and we built this application called Author. There are many such applications, by the way, but this is the only one because I have personal involvement in this. I could put it on a slide. Essentially, it's a LinkedIn ghostwriter. And you can build this on your own in N8N. If you pick up a few coding skills, and a little bit about the agentic AI architecture, you could build something like this yourself within a couple of weeks, or probably even less. And it just lets you write this LinkedIn post on a daily basis within 10 seconds. It will learn from your previous LinkedIn post, so you have to give it access to your LinkedIn. So it knows your tone of voice, unlike ChatGPT, which writes it in a very generic tone of voice. It knows how to write posts because it has studied all the a lot of previous posts as well. And essentially, I think they are planning to make it open source. So it will no longer be behind a paywall. Anyone will be able to go and use this. Another one is if you are in an enterprise, right? How do you, as I mentioned earlier, get value, which is significant value to a lot of workflows, employees, and that is through one of this application like this, which is called Coderbotics. It's by FX31 Labs. Again, I have a partnership with them. What they do is when we were doing digital transformation 10 years back, we would have a lot of legacy code in the organization written in languages that were no longer supported. Some were open source, some were not open source, but there was no longer developer support available, and a lot of new technical frameworks had come up. So you used to have these hundreds of thousands, and sometimes in some cases millions of lines of code and functionality that had to be then put into a digital transformation program, allocated budgets to, and then transformed into something new like Python or some other new language. Coderbotics will essentially take all of your code and refactor it into whatever new language you want, and it will do that module by module. And you can imagine the cost saving for a large organization. Again, there are many other applications like this. So I urge you to go and search for them as well if you are in a large organization and this is something that interests you. But essentially, any kind of language, whether it's SQL, whether it's Python, you can refactor the code very easily using generative AI. I think I have one more. Unfortunately, I'm not allowed to name this one, but I thought that because we are at Zinc and we're so embedded in the startup ecosystem here, I should mention this. And there are several. There is one coming out of Y Combinator also. I want to say there's an application which I don't have the name of. This is an agentic MVP builder using generative AI. So if you combine Gen AI, agentic, and startups, you have this MVP builder that can act like your tech and your product team. And the whole hypothesis is that early stage teams are wasting so much time aligning designers, developers, testers to just build an MVP, to get funding to get them going on the back of that MVP. Instead, they could just have this MVP builder, build them a tech application very quickly, and they could iterate on that based on user feedback. I think finally you have some ethical considerations. I won't be able to go into a lot of, because this is a field by itself, I won't be able to go into a lot of details on here, but essentially data privacy and security is sometimes a problem with Gen AI. We definitely have a problem with bias because the data that is input into these models then controls what the output is. And if you enter biased data, you are going to get biased outputs. And job displacement is a real concern as well, but it's not happening now or yet. However, it is something that is being watched very closely. There you go. There are some further readings. All my mental models related to work were in this new book called Reshuffle by Sangeet Paul Chaudhary. It's a really good book. All the 4 items that I mentioned, they are from this book. Then The Coming Wave by Mustafa Sulaiman. I think, Lucy, you also recommended this book as well. It's a great book. Co-Intelligence, I think it's a little old. I had read this a while back. And then Yuval Noah Harari's Nexus also is slightly older. Not old in the sense old, but in the world of AI, I guess 6 months is a very long time. And that's about it. So if you want to start with AI, I would say start small, build your muscle through experimentation, don't wait for permission, and just use AI to amplify your strengths and not your weaknesses. Thank you. Do you want to do questions? Yeah.
Yeah, amazing talk. Thank you, Rosh. We think we've got about 10, 15 for questions. We also have some people online. So
Okay.
anyone online, please feel free to put your questions in the chat, and we've got someone who will field them through. Does anyone have questions?
Thank you. It was
You're
great.
leaving, aren't you?
Yeah, just kind of a quick question before I leave. Sorry,
Sure.
it was great. A blind human has general intelligence, right? So just wondered whether your definition of the general intelligence is missing something. Might be philosophical, but so I always thought of general intelligence as an interface. It doesn't need to be a robot. It doesn't need to see. It doesn't need to. But I can sort of speak directly, and they give an creative type of response that at the moment is still lacking. But just a thought. Just a thought.
Yeah. So I mean, I say that vision in the case of that visually challenged person is substituted by other forms of intelligence. They do feel their way through, for example, and that gives them a mental model or a sense of the world. I guess the concept here is whether you have a theory of mind, right? Whether you know what your mind is. It's a meta of, I know I have a mind. So yes, you're right. It is philosophical, but and I don't know whether an AGI can eventually develop to that point where it says that, yes, I have a mind. I know how to feel things. I know how to sense things, and I can make sense of the world. So yeah, in some sense, it's philosophical, but it's also that you can substitute vision with other senses. Yeah.
Great.
No worries.
Thank you very much, Rosh. That was fantastic. So I'm a teacher, and one of the, I'd say, concerns that I have with AI is that there will be a vast difference in the access that young people have in AI in terms of, so I teach around in this area, so in terms of their economic accessibility. So my question is, what would you say for me as an educator? How would you encourage or introduce AI to young people today, and in a way that will help them not become even further away from people who have more access already?
So I definitely, I hear your concerns, and I think it's the same with any kind of technology, right? For example, even smartphones. There are various places in the world that people don't have 5G or even don't have access to smartphones. But I would say that as a comparative, AI, from what I have seen, has the most open source tech and information available. So there will definitely be more opportunities for those students to access AI. They obviously have to be interested in in those aspects, and some of it can be quite daunting to start with. But the number of videos that you see on YouTube, Instagram, on tech, not just videos, but programs that you see that are freely available on something called Hugging Face. Hugging Face is a machine learning open source program. So the number of tech artifacts that you see that are open source within the field of AI is much wider than other technology. So there will definitely be opportunities for them to access that. It's a very practical consideration, I know, I agree. But yeah, I mean, if you want to, we can have a chat later on some examples that I can give, or I can search for you. Yeah.
Okay, thank you.
Thank you very much for the talk. I think 2 questions from someone who doesn't know too much about it. One is, if I was going on that tool that you showed, and there's an AI for that, how can someone who doesn't really know much about the underlying architecture figure out what the quality is of said tool? Because you said, in the top 10, there were names that you hadn't
considered or that you weren't using. And I assume you can kind of judge whether the quality is good or bad. So that is one. And the other one is because there are so many applications now,
Yeah.
do you think there will be a wave of consolidation down the line where lots of the small applications become one bigger application? Because for me, it'll be a minefield trying to go through all of the different ones, and probably more practical having just one that does lots of the little things together.
Yeah, I mean, look, there will definitely be consolidation, right? There is, it happens, again, the answer would be the same as I gave before. It happens, you have to learn from the past. And it has happened with various other kinds of tech that came up, whether it be med tech, fintech, we go through various cycles of technology, and there's eventually an explosion of a lot of applications, a lot of tech coming out, and then there is a consolidation, right? The bad ones will fall out eventually. There will be consolidation. It's probably down the line, not coming up anytime soon. Again, but I would say that it is so easy now to build good applications. You don't need to code. The code will be generated for you. You don't need to know how to work an API. The API will be generated for you. Everything just needs to be assembled. So, the application quality will tend to go up in any case. To answer your other question, I think there are ratings. I need to check on that side, but there are other sites that do give you ratings and user comments and views as well. I always start with the free applications first. They aren't the best usually, but it at least gives you a hang of how to use it. And then you can get to the more expensive paid ones.
Great. Got a couple of questions online, which I'll read out for you, Rosh.
Sure.
So Kathleen asks, we're watching AI slip deeper into critical infrastructure, finance, everyday operations. Adoption feels fast and the stakes are high. For you, what is the single weakest link in our current cybersecurity posture that keeps you up at night, if there is one? And why aren't we fixing it faster?
I don't know much about the field of cybersecurity. I will mark that as a caveat. I think what keeps me up is not necessarily just AI, but the looking ahead, the combination of AI and quantum computing. That, well, that would be, you could break most of the passwords, banking passwords that we have right now. So that does keep me up. There are fields coming up. There is quantum cryptography, a couple of other fields that I don't remember at the top of my head that are looking to address these concerns.
And another one from Jessica, how optimistic do you feel about society or a world powered by general AI or super intelligent AI?
Okay, look, there are, this is a question that is often asked. I mean, I've heard a lot of podcasts around it. There's always two extreme camps. There are people who are always scaremongering, saying that what happens, when a super intelligence comes up and takes over. Obviously, why will it be kind to us, right? Are we kind to all other human beings? We are the most intelligent species on the planet. But there are times when we are kind, there are times when we are, bad to other human beings as well. So there is that camp, but then I am an eternal optimist. So I take the other view that we will find a way to mitigate those concerns at some point. So it is daunting, it is scary, but yeah, I think tech will evolve or develop to that point.
Fantastic. Well, we're at time now at 9:30, but I'm not sure. I know Rosh is staying around for another half an hour. So, Lucy, you've got a few questions. Feel free to ask them. Yeah, thank you again. Please join me in just thanking Rosh for.
Thank you.
So this was a kind of, I guess, a deep dive or a quick on the essentials of AI. For anyone who's here interested or thinking about the Inflection Fellowship, please stick around and we can have a chat. We'll also share all the slides afterwards. So if that was any of your questions, we've also got a full recording. We'll stop there. Feel free to stick around. We've got some breakfast. People are milling around now, I think, for a bit of networking. Thanks again, everyone.
Hi, folks. I am going to stop recording. Let me just do that.